Hi everyone. What I'm going to do today is take you through a little bit of a structural approach to coding and commenting. Now I got to tell you, I did this once before and it was one heck of a screencast, except it didn't take. So I'm now running new screencasting software and hopefully this time it'll work much better for what we want to accomplish. In any case, what I want to do is I'm going to do this in pseudocode. I'm going to take you through the process of how I tend to code in terms of structure and layout, because I've talked to a lot of you about structure and layout, and it doesn't appear to be that in many cases you really grok what I'm talking about. You really understand what I mean by structure and layout in terms of how to look at your code. So I'm going to deal with a really simple example, and I'm going to start it up here. Let's start over with a simple function. So let's say we have a function, okay? And let's say we want it to be, I'm fixing my glasses here for a sec so I can see the screen. Let's say we want it to be something simple like open pod bay doors. Bay doors, okay? What we want to do is we want to have some content inside the function, and so that's our rough structure for the function. Now, a couple things we want to look at right here. I've put brackets here and here. Other people will code with their brackets like this, and the code that goes on in the middle of the bracket here. Both of those are valid, and for the longest time I actually used to code this way. And so if you had a couple of functions, let's copy this, you'd be able to say, okay, well, here's the function, here's the code, here's the function, here's the code. But I found that as I wrote a lot of code, the density of it became a bit of a problem. And I was able to save some space and identify where the beginning of the code was very easily by doing it this way. Now you'll notice something else. I've put a space after the parens and the open bracket. I didn't just leave it, I didn't just leave it like this and have a couple that are, you know, mismatched a little bit. I have a consistency of, look, I'm also not in some places having code here, you know, and let's say for this one, my code ends there. I'm not having this down here and somewhere over there. This code, the way it looks like this way, would actually work. I mean, it would actually function, but it's much more difficult to see what's going on. And this is the important part about structuring code. It's designed to help you see what's going on. So let's clean this up. Let's bring this back up here. Let's make sure this has a space and that has a space. So you can see now that that's much cleaner. You can get a pretty good feel for what's going on. So, and obviously right now all we're doing is we're opening the pod bay doors. So let's say we want to add a couple more functions that we're going to fill out the code with this. We're going to want to have one that, let's say, closes the pod bay doors, right? If we're opening the pod bay doors, we're going to want to close the pod bay doors. So we have closed pod bay doors. We probably want to do a test to see whether or not the pod bay doors are open. So we'll have a test, are pod bay doors open? And we might have another one, which is get a failure code. If something goes wrong, we'll want to know what the failure code was. Failure code. So let's deal with a couple things here. Now you'll notice that in this set of definitions, I have an open pod bay doors, I have a closed pod bay doors, I have an R pod bay doors open. What I don't have is this one isn't called open, and this one isn't called close, because there may be a whole bunch of other functions going on. Let's say I have to open a file, I have to check a status, I have to do a lot of other things. I didn't use generic names for that. I also don't call this Bill, and I don't call this one Ralph, because that doesn't help me diagnose things. I'm not writing this in ancient Latin. I have a friend of mine who programs in ancient Latin. That is, he programs a traditional programming language, but he comments all his code in ancient Latin. He was a double major. The point of this is it's almost impossible for anybody else to maintain his code, and that's a problem. It's a joke. He calls himself Aristotle, but the fact is he really should be programming in a way that's understandable. So We also aren't doing, let's just say, CPBD for closed pod bay doors, because while it may take less typing now to have closed pod bay doors and our pod bay doors open, if you come back to this in, let's say, 6 weeks, 9 weeks, 12 years, you won't know what this stuff is. Whereas if you come back to this even 10 years from now, closed pod bay doors, it'll be clear that that's actually what it is, and this is our pod bay doors open. So you'll be able to look at your code, and when you come back to it, be able to tell, all right, well, in fact, my code does make sense. Now, you'll also notice, again, when we're talking about coding consistency, I have the parens right after the function name. I don't have one or two spaced. I don't have a few things like this. I have the parens that define my function right after the function. Again, this is a coding standard that you can decide you want. If you wanted to make your code, let's come down here and just duplicate this for a second. If you always wanted to make your code look like this, that's acceptable. That's not something I'm going to grade you bad on, but I want all your functions to look like this. I don't want just one or two functions to look like that. I want that to be how you structure your code, if that's how you choose to structure your code, or if that's how your employer if that's how your employer tells you how to structure code, or that's the standard for the environment you're building in. There are styles, and as you can see, the style between this function here and this function here are substantially different, even though they're essentially the identical function. So I'm going to go back to the version that I have, and we'll do it this way. So that's one of the places where we want to look at things. Now, let's also take a look at the functions themselves. What happens when you open the pod bay doors? Well, it can succeed or it can fail, right? So this should probably be a Boolean. A lot of you, when you're doing things like opening files and closing files, aren't checking for the results of what happens. So you open a file and you try to read a file, and you assume, well, okay, I'm reading a file, but you don't check to see the results, and you don't check to see what happens. So let's go back here and go Boolean again for a function for closed pod bay doors, because that probably is, again, returning a true or false. Now, obviously, you could have other things to it, but I'm simplifying here. Now, our pod bay door is open. That too should be a Boolean, because that's going to return either yes or no. You could change that to, get pod bay door status, in which case you'd get something else. But for the moment, our pod bay door is open, you've got a Boolean. Whereas get failure code is probably, an integer value of some kind. So already we're beginning to see, if we look at this code, we're like, okay, well, this function will attempt to open the pod bay doors, and it will return a success or failure if it doesn't. And you can see this just from the definition of the code, and you can see them side by side together. You'll notice that there is one space. You can't really see it here, but there's one space there between each of these lines. I'll just type a bunch of stars there. You can see there's one. Oops, hang on. Copy. There's just one blank line between each of these things. Again, I'm looking for coding consistency, and also not to nuke my lines. All right. So let's move on a little bit, and let's look at what we might deal with in terms of thinking about how we're approaching our code. So when we look at an assignment, I'll often talk about breaking things into functional parts. So let's think of what some of the functional parts might be for opening the pod bay doors. Well, you might have a set of declarations, right? Okay. And I actually like a space after my comment. So I notice I'm doing one tab, 2 bars, and a space. And that's going to start a chunk of code. Whoops. Just bring that up there. Okay. So I have declarations. I might have something that deals with the pod bay doors on a regular basis. So let's just say I have a pod bay door loop. No, I don't even want to loop the pod bay doors. What I want to do is I want to find out what the status is. So I want to do like a pre-open status check, right? Then what I want to do is I might want to do some kind of validation routine based on the status check. Then what I might want to do is, let's see what else might I want to do. I might want to do some kind of post-validation status check, right? Or post-operation status check. And then end out my function. I might want to check to see are there objects in the pod bay doors, right? So I might do a check for objects in pod bay doors. I might want to then allocate power for opening doors. And then I might want to send an actual door open command. And then I might want to check after. Then let's say I want to send back result of open command. Okay. And in this context here, in the pre-open status check and the validation routines and so forth, I might want to have, let's just say, I don't need a loop here, but let's say I wanted to put this in a loop. And I want to do that so I can show you again indenting strategies. So let's just say I want to put this in a loop. So I'm going to do a loop, and let's think about this for a second. Let's open the loop with a bracket. Oops, where are we? Here we go. Let's open the loop with a bracket, and we're going to close the loop with a bracket. Now you'll notice again I've indented. Now these are not indented, and unfortunately, since I'm doing this thing in text in Notepad, I have to move these by hand, but that's okay. Just go ahead and move these by hand. And again, as you can see here, it's kind of clear what's going on inside. There's a loop, and let's just say that that loop is a timing loop for the pod bay doors. So let's put a comment in here. Whoops. Get rid of spurious markups there. Let's call that a timing loop for pod bay doors. Okay. And then inside that loop, let's just say that in terms of the pre-open status check, let's say I want to have some code, right? So I've got some code. And then I want to do another loop that, let's say, waits for the status. Loop. Do the same thing here. And I'll put some code inside. And I'll close the loop. Let's say that I want to say something in here, waiting on status. Now notice that there's a couple of differences between where I put my comments and where I put my spaces. This is really important in terms of how we're structuring our code. And this is why I want to come back to you and talk to you about code and structure. And it'll make a little bit more sense in a minute because I'm going to do some decorations up here. And then you'll see a little bit more of how that's going on. So let's say I need to have a couple of commands here that control this stuff. So I need an integer that's a door open command. And let's say I want that to be 22, and that's called the code to open doors. Then I have another integer, door, let's call that door close command, and that's going to be 23. And in fact, let's tab over, make that nice and clean. Code to close door, and probably close doors. Okay. And then let's have another command here, int door slide command, and make that 24. And that's code to slide doors, just in case we want to have it just move back and forth. Now you'll notice a couple of things are going on here. First off, because I use naming that's really clear, I almost don't need comments, but I put comments here on the outside of each line. Now, I could put them right there, one space over. This is one space over, this is one space over, and this is one space over. So I could put them right next to the code, and that's perfectly valid. But sometimes when I have a whole list of declarations, I like to make it really, really crisp and clear to see what's going on. And in fact, sometimes I get truly carried away and I'll do things like this to make sure that everything lines up so I can really easily see at a glance what my stuff is. And your development environment will allow you to set tab stops. In Notepad, I don't have that option, so I'm setting my tab stops here. But also one of the other things that I want to point out is you'll notice that I didn't stick my declarations in the middle of my loop. Let's say the first time I need the slide command is down here. I don't define the door slide command down here in the middle of the thing for the first time. I don't take it out of here and just have it defined down here. I have all my declarations up on top. So it's up here. And I'll bet you can notice something if you look at this. If you notice, look down here, you can see that there's now 2 lines between these, let's see. Let's just bring this over. You can see there's a line here, and there's a line here. There's 2 blank lines between check for objects in the pod bay doors. And if you look at the code at a single glance, you can see that there's something there and that there's extra space here, which means that you can see that there's something missing. And that's a key point, because that's why I want you to have universal and consistent spacing. Because I can look at my code now. I can come into my code. Let's say I've gone out for coffee and I've come back from my code, and I can look and I can see that there's an extra space in this spot. And because there's an extra space in this spot, I might think, well, maybe I deleted something I shouldn't have. Or maybe I'm planning on adding something there, because it's telling me something. By having consistency in how I lay my code out, it's already telling me something about the code. Just the extra blank line tells me that maybe I put something in there and took it back out, and why I've done that. So that's really important. And now I can look at it and go, okay, that's much more consistent. All right, so let's come up here and let's define a couple more utility variables. So let's come up here and say int, let's go CDE equals 0. And let's just call these utility variables. These might be used in simple assignments or simple loops or something like that. What I tend to do is I tend to create utility variables up front that are just very basic things. Then I have declarations of things that really matter. But all my declarations are up front. And with the exception of simple assignments, my only assignments are done, only the simplest of assignments are done in this initial block of code. If I want to add something, let's say I want to have the door slide command, and let's say the slide command is actually a Boolean that says how open or closed it is. So let's say, for argument's sake, we have another function which is int door slide, door slide amount. Okay, and let's start that with 0. And what I would have here is I'd have a comment that says 0 is closed. It's called 255 is fully open. So all of a sudden, what you can tell is the door starts closed. This is the range of code, and it's right there. It tells you where it is. But if I wanted to have a function that said, let's just say I'm doing an actual door open command, and I want some kind of for loop to close. Let's just call it a for loop. I'm not going to stick variables in here. You can figure it out. But let's just say I want to say decrement the door slide amount. I'm doing it down here in the code. I'm not coming up here and going, I'm not saying in the middle of my code somewhere, int door slide amount equals 0 plus door slide command. It's hard to tell where your variables are and what variables you have defined if you do something like that. So what happens is by having whoops, let's clean that up a little bit. By having all your declarations in one place, you're able to tell, okay, everything I should have defined is up here. This is my data structure. This is the component of how you're defining your data table, and it's all here, all in one place. What I do, and this is you'll notice that there's different kinds of rough comments. I have a comment freestanding on top of whatever the loop indent is for the section. So this is the declarations section. And then I have inline comments for anything specific that I think is important to comment. Now, if I have, let's just say, 10 lines of code here, I may not put a comment on every one of these lines because some of it may be relatively obvious. But I would put something here because I'm telling it that it's waiting for status. So that's a piece of how this stuff gets put together in terms of its organization. But the other thing that I want you to look at is as we look at these different pieces down here, let me take a look at my notes for a second. So let's take a look down at the way I put together these big Boolean functions. Because one of the things that becomes an interesting question is how do you define where you comment on your functions as well? And one of the things that I like to do is I like to block off, and this is for big code. For small code, for what you're doing, you may not decide to do it because it does take space in the document and makes it a little harder to read initially. But I often do something like this, where I put this nice long, I just cut and paste this from a side set of notes, where I really put a section in here that says, okay, this is the function for the HAL controls, and this opens the pod bay doors. And then I might have another one here for the closed pod bay doors. And as you can see, it says close pod bay doors and returns true. And I don't have perfect tabbing here, unfortunately. But I might do something like that, or I might just decide to leave it indented like this. Or I might just do that because it's just as clear. Likewise, I might come down here and do the same thing for the door status. Now you'll notice that what happens here is by doing this in front of the Boolean code, I'm saying this returns true if successful, false otherwise. So if you look at this, you'll know, okay, it's going to do something. Also, it's Boolean and it says return, so somewhere in your code should be a return value, someplace in the space. And this should be pretty close to the end of your code or inside let's just say, if failure, return failure value. So you've got something going on in here. Now I tend not to start my code directly below the first line. I leave a blank line. I have code with a bunch of lines of code that relate to something. Now I would almost always put a comment here and say, about this section and have some code in there. And then at the very end, I'd have a blank line and return the value. We'll come down to this section here because we didn't document this. This one's interesting too, because this is get failure code. But what is our failure code? So let's come in here and paste this in. Make sure that we have one line there and we have one line there. I'll come back in here and notice that this is going to be returning a value. And so as a result, what I want to do is I'm going to have at some point, I'm going to have a return value at the very end of my code, because that way I know already, because I've just determined that these things are one Boolean. This is an int. These are Booleans, but that they are going to return a value, and I can see where that value is going to be returned. So we want to look at this stuff from a structural point of view and understand kind of how these things are put together. Let's go through this one more time. Let's take a look. Each one of these is a section, so there's going to be some lines of code, right? Notice after the section is a blank line. Let's do a little bit more here. Code, code. Let's drop a loop. Now, if it's a short loop, it just has 1 or 2 lines in it, I might just have basic loop and then end it, and then maybe have some code later. But if this is a major loop and has a lot of stuff going on, I might then break it apart. Now, it's still under this major section, so you'll notice that I'm not putting an extra section of comment in here, but I might put inside the loop, I might say that this is, let's just say code, and then I have an if statement, if say A equals B, code, else, oops, close the bracket, else, open the bracket, code. Now notice that there's a blank line here, okay, right in this spot. I'm going to do another little set of stars there. Notice there's a blank line there. It's not entirely clear with that extra blank line what this belongs to. Does this belong to this? Does it belong to this loop up here? What does it belong to? So if I bring it up and there's no blank lines between these two things, I can tell that it's all part of the same chunk. So for example, if we look at this piece of code, let's just call this code A, B, loop A, and code C, just for kicks. I can tell just because of how I've, let's format, come back in here for a second, say a little bit more code here. I can tell just because of how I coded this, that this chunk with code A, code B, loop A, and loop C is all part of checking for objects in pod bay doors. But I can also tell that these two are related. They do part of things together. There might be another sort of mid-level routine that's in here, and then another piece of code here that's not directly related. So I've broken it into chunks that help me understand the logical piece of this. So let's say, for example, that this code here evaluates, let's just say, calls scanning laser, or let's say aims scanning laser. Powers up scanning laser. Powers up scanning laser. And this piece of code, scan for debris. All right, so these two things go together. It's powering up the laser, it's scanning for debris. This piece of code in here is going to do, let's just say, this basic loop is scan until debris gone. All right, so we now know that this loop, this whole chunk of code, is going to scan until the debris is gone. This is going to be something like remove debris, and this might be something like exit routine debris gone, and this might be continue to remove debris, something of that order. And then this is power off scanning laser. So what you can do is you can kind of look at this chunk of code, that's this chunk of code here, and you can tell that this is all related to checking for objects in the pod bay doors. It's not about allocating power for opening the doors. It's not about checking the operational status. It's all about checking for objects, because where the next major block comment is here, this is the block comment here, but we've got two things that go together, the powering up and scanning for debris, and let's just say maybe that's not scanning for debris, maybe that's, maybe this one is allocating power for scanning laser, and then this one is powering on scanning laser. Okay, so they go together. You've got your power allocated for your scanning laser, and then you've powered it on. Now you're scanning until the debris is gone, and then you power it off. And so you can see how by looking at your code, by looking at the structure of your code here, in one shot, you can kind of tell that this is one section. Now, what becomes really interesting, and this is where it starts to get really kind of cool, is if you do something like this. So I'm just going to grab, let's grab a pile of code here. Let's just grab this code. And let's make this code and code and code and code, okay? You know that, let's say this is getting really complex. In fact, let's make this code and code and code. This routine is now getting a little too big. It's too hard to see what's going on, especially as I've come back to it and I've done a little bit more work and I've got some more code in here. So I know that the function that checks for objects in the pod bay door starts up here and comes down to here because I know that the allocate power is here. So I could then decide, for example, to take this entire chunk. I'm going to cut it. I'm going to come down here and create a new variable. Boolean is there junk in pod bay doors. Drop that entire chunk there. Have a return. I should probably move all this over, but I'm going to come back up here and first call it. So I've copied that. This is where my code was. You can see where my code was, even though I pulled it out, because there's 2 lines here. So you can kind of see where this is. So now I'm still going to have check for junk in pod bay doors, but this time it's going to be if is there junk in pod bay doors. Oops. Do something. Okay, so now I've taken this piece of code and I generally do that. I'll generally keep my parens inside and I'll put a space after the Boolean logic. But now I have this smaller piece. So again, I can look at my routine and I can see what's going on. And then down here, I have this is there junk in pod bay doors. And the thing is that I know it's not finished because first off, it's indented too much. So at a single glance, I know that there's work that needs to be done on this code. Number 2, I can see at the back, there's nothing at the back end. Again, I know there's work that needs to be done on this code. So what I can do is I can just finish this off. First thing I'm going to do here is I'm going to come down a line because I like to leave a blank line, and then I'll move all of this over. Now, normally when you're coding in your development environment, it's just really easy to do this, but I am doing it by hand for you because I'm that kind of guy. But what I'm going to do is I'm going to cheat. I'm going to delete all this extra code because you know what it does, and I don't have to put myself through all that. Then I'm going to come down here, bring this in. Now I know I need a return, so I'm going to come in here and do a return of some kind. So I'll return my value. Now I know I haven't closed it. Remember, I have a coding structure. I have a pattern. I have a method that tells me at a glance that I haven't finished my code. So I can look at this, and I know that there's something up here. There's nothing down here, and it's not that, like some of you will do at the end of your code, jam something in there and hope that it's done. At that point, you can't tell whether you're doing something, but because I always have my ending brackets at the bottom, I know that that's done. Likewise, I can look at this code and go, this is really ugly. I know my code has a style. So I know that this is going to be indented. I know this shouldn't be here. So I'm going to bring this back and make it all fit together. And then I might create a new comment in here for what it is. And so I might say clean junk from doors, right? And returns true if, let's just say junky, false if clean, right? Because in this case, is there junk in the pod bay doors? You want it to be true, there is junk, and you want it to be false because there's not junk. So what we've got now is, because we define these things cleanly, we can tell, okay, we've built this piece of code, we pulled it out because it was getting too big, we created a new function down here. The function is kind of clear. Now you'll notice that I go straight from loop to all this code. It probably needs to be broken out, and the code here probably needs what's happening in this section. Again, to make it clear what's going on and clear how to make it work. So what you're seeing here, if I want to wrap all this stuff up, is you're seeing comments, how I place the comments, sometimes in big chunks. I do these big blocks of comments around functions at the beginning of functions separated by a single space. There's a big block here. There's a big block here. Now you'll notice that these don't match. And at some point I would catch that because it would bother me. So there's a chunk here. There's another one here. There's another one here which defines this function, right? So here's this function. There's this function, and so forth. So we can kind of tell what we're doing in this code. Now the next thing, again, in doing our recap, is I have sections that are broken out by simply having the comment align with the block. So the comment goes before the block of code, whether it's a loop like this is, or whether it's just a couple of lines of code. The comment aligns with the code block like this to make it possible to be able to see where your code is. Then I have comments at the end inline in the code, which allows me to see what individual lines do, and very specifically what that line does. Now you'll notice that nowhere in here do I do the old style C commenting of /* old C comment */. That's a preference. For once in a while, I would get myself all carried away, and I would make these nice little star piles up here, and use that as a way to clean things up. But I found it just was not consistent enough, and I found it was much more consistent in terms of seeing things that comments were always 2 slashes followed by a space followed by what it was I was commenting on. I only keep one line of blank lines between things, because if there's more than one line, it means there's something I need to pay attention to. It means I either cut something from something that needed to be worked on, or I removed something, or I made a mistake somewhere, or something like that. The indenting structure is really important. So all of these things go to what I call coding style, coding structure, and your commenting regime. And that should give you a much better idea of what I'm talking about when I grade you on and say your code is structured cleanly or not. This is nice, clean code. Or I'll say that your code is structured inconsistently. And sometimes when all of this is, like, for example, some people will give me code that looks like this, and then, there's 3 lines here, and then this piece of code is over here somewhere. And I mean, it works, right? And then this is here, and there's a comment here that says, some of this is something I did above. What we want to do is we want to make this stuff clean and understandable. So let's back this out. Okay, apparently Notepad doesn't back out nicely. But you see how difficult this is to process, whereas if it's clean, you might think this is a different section. And if it's a different section with some different logic to it, either it's a bug, but if it is a different section, you'd add different section comment. So you know that these are 2 different pieces of code that are meant to do different things. And in this case, this doesn't have a whole section comment because it's really just one line, but the one line is commented and it's separated out from this. So it's all kind of clear. And then I have 2 lines here, which means there's something probably screwy. So I've cleaned that up, and I've cleaned up that, and then we have clean code. And there you go. That's going to be my structural code discussion for today. I hope you had a good time, and send me clean and commented and structured code from now on, okay?